Hello Calculus student, this video is for 4.7 part 3, the last example of 4.7 optimization. So in this particular question, we are optimizing revenue. So a company finds that if they price their product for $60, they can sell 100 items of it. For every dollar decrease, they can sell 2 more items. What price should they set for the product for maximum revenue? So this often happens. Sometimes a merchant would want to increase their price of the product, but then they will sell less. But sometimes they actually had more revenue. And now in this particular case, these merchants want to decrease the price so they can sell more, and apparently they can actually get better revenue. So let's how do I do this? So we have to maximize revenue. Revenue is how much you sell per and then times the unit price, right? So we'll just write it as revenue is equal to the number that you're selling times price. N is the number you're selling, number sold you can sell. Right now they're selling 100 items when it is priced at $60. Doesn't move. Number sold. And price is the unit price. So if you sell N is 100, then your price is 60. So but then because if you lower your price, you can sell more. So we can say price is, or actually the number that you sell is 100 at something. Okay, how much? You can sell $2 more if your price decrease. So how do I know how much it decreased? So the new price is P, and then you're selling 60. So 60 minus P would tells you how much it decreased. And for every $1, so we'll say sometimes in other question it will be like for every $5 you sell 2 more, so you would do 5 here. But in this case, for every $1 you sell, you decrease. So how do you find a decrease? Is that your current price minus your new price, which is lower because you're decreasing. In question where you are increasing your price, so this would be a it would be 100 minus, and then this would be price minus 60 or something. So you have to adjust this sign when you are increasing or decreasing price. In this case, you're decreasing your price is lower than 60, and then because of that you have 2 more for every dollar increase. So you write this as a relationship between price and number, and now you're going to plug it in, right? So R now, because you want to maximize revenue, so it would be 100 plus 120 minus 2P times P. We haven't simplified it. We should actually simplify it. So it's actually 220, this is a minus 2P times P. So revenue is actually 220P minus 2P squared. It's a very simple expression. And what about the price that you can set? Of course, you can lower it until 0. And you can keep your same price. You do not want to lower your price, right? So this is a closed interval. So you can do extreme value theorem of finding absolute max. So you just need to find your critical number. R prime is very easy to do. 220 minus 4P. So what is P? So 0 equal to 220 minus 4P. P is equal to 220 divided by 4. That is 55. So at $55, apparently that is a very good either the maximum or minimum. So let's build a table. So we say our price could be 0, the lowest. It could be 60 because these merchants just want to lower price. And then the 55 is the critical point. So what is the revenue? So if I plug it in, I use decimal to help me. Where is it? Okay, so I have decimal here. That was from the last question. This one, 220p minus 2p squared, and then I have g of 0 is 0, g of 55 is 6050, g of 60 is 6000. So I have 0. Of course, if you don't price anything, so it's free, so you don't earn anything. So we know that this is what 6000 And this, you can gain a little bit more. So this is the absolute max in this interval. So what price will it be? The price is $55. Will give you a maximum revenue of $60.50, more than you have if you price it at $60. So that's all for 4.7 part 3. For part 2, I think I ran out of time, but I built a table here for the question. So it was for this swimming question. So the time is, you do look at this table. It's 1.41 and 1. For 6 is 2.1. So yeah, so the lowest is 1.36, which is at 0.809. So how much would you run? You'll run 6 minus this. You would leave 0.809 for the shore, so that you can jump into the water right away. So it's 5.191.